Hi guys, Mrs. Delisin here again. Welcome to another lesson of Algebra 2. Today we're going to be learning Quadratics 5.1, the imaginary unit. What is imaginary unit? If we are tasked to solve x squared plus 1 equals 0, the first step that we would do is to subtract 1 on both sides, correct? And so you'll end up with x squared equals negative 1. And then you will, of course, square root both sides and you'll end up with x equals plus and a minus square root of a negative 1. In the past, maybe when you were in middle school, you were told that you cannot take the square root of a negative number. So that is true because if you put the negative 1 in the calculator, the calculator will say error or undefined. If you put the square root of a negative 4 in the calculator would also say error. And that's the reason why when you were in middle school or maybe when you were in elementary, you were told that you cannot take a square root of a negative number. But sometimes the we have equations where we're going to end up with a square root of a negative number, and we call that one the radicand, the number inside the square root. And what do we do then? Now, the definition of the imaginary unit, it's in here. Let I be a number such that I squared is equal to a negative 1. So I squared is equal to a negative 1. And if I squared is equal to a negative 1, that means the square root of a negative 1 is I. That makes sense? And so every time I see a square root of a negative 1, I'll treat that one as an I. How does that work? Let's try a couple examples here. So in number 1, we have a simplify each number. So we have a square root of a negative 81. So let's put that one. I squared is equal to a negative 1. Therefore, that's I times I is equal to a negative 1, right? And we know that a square root of a negative 1 is just I. Okay, we're good at that. 2I, so I times I is square root, I times I is I squared, so that is negative 1. And so if I have a square root of a negative 81, because I have a negative 81, let's take out the negative out of the 81 because we know that the square root of 81 is 9, correct? But what if it's a square root of a negative 81? So I'll do square root of 81 times square root of a negative 1. Does that make sense? And I know that square root of 81 is a 9 because 81 is a perfect square. And so if the square root of 81 is a 9, and then a square root of a negative 1 is I, that means the answer to this is 9I. Correct? Done. That's it. That is your answer to the square root of negative 81. Does that make sense? So the difference between the square root of 81, which is 9, is just the I, right? You just add in an I to it. Let's try another example. We have a square root of a negative 5. So that means this is a square root of 5 times square root of a negative 1. And, oh, wait, can we still simplify square root of 5? We cannot, yeah. 5 is not a perfect square. So square root of 5 will still stay inside as the square root of 5. And we know that square root of a negative 1 is I. Therefore, our answer here is square root of 5I. Now, in some cases, when you write this, you know how, this one is in outside the parenthesis, outside the radical. A lot of people get a mistake on putting this one as a square root of 5I, which is wrong. And because of that constant mistake that students are doing, I am now requiring putting an I before the square root. So you are, instead of writing it as square root of 5 times I, you're going to write it as I square root of 5. Just that so we can avoid you putting the I inside the square root or inside the radical. Okay? Make sense? But if you put an I right after the square root of 5, that is not wrong. I'm not saying that that is wrong. I am just saying that we should avoid, those common mistakes that people are doing all the time. Now let's go letter C. Oh, we have a 54, and we know that 54 is not a perfect square, right? So let's try to factor 54. 54 is 6 and 9. 9 is 3 and 3. So because I already have a double, I'm now going to stop because 6 is just 3 and 2, right? And there's no double in there. So I'm just going to stop when I get the double. Okay, so we have 54. The square root of 54 times square root of -1. And we know from the past that when we have a double, double goes out, single goes in. So the 3 will be outside the radical, the 6 will be inside the radical. Or I will show you another way of doing that. But for now, we have square root of 54 is 3 square root of 6 times I, because square root of -1 is an I. And so all we have to do is combine all of this. And remember, I want you to put the I before the radical. So our final answer would be 3I square root of 6. Now, Miss, I'm so confused with why the 3 is out, why the 6 is in. Another way of doing that is you could do put all the factors in here, 3 and 2. So you have 3 times 3 times 3 times 2, right? And usually when you get the double, that's 9 is a perfect square, that's why. And every time you have a double, double up, and then these two single will go in, and that's a 6. That's another way of you solving it. Okay? Now let's move on to another one. Square root of a -75. Is 75 a perfect square? No, it's not. It's not a perfect square. And we have 25. Okay, common mistake that people are doing in here. You guys divide this too. And please know that you cannot divide the 75 and the 25 at this point because they are not the same term, right? They're unlike terms. And another quick reason, simple reason is the 75 is inside the house, 25 is outside the house. And you can't combine them in unless you work through first on 75 and putting it outside the house. So let's work on 75. Let's try to do this. Let's change the color so we can see the difference. -75. So you have negative, don't forget the negative, and then you have a 75 times square root of a -1. And of course, that's just 25. No, no, not square root of 25. And let's make a factor tree of 75. What's 75? 25 and 3. This is 5 and 5. Double goes up the parenthesis. 5 goes outside the radical. 3 goes inside the radical. So the 75 will turn into 3 square root of 5. Or that is wrong because 5 goes out. So 5 square root of 3. Okay, so you have 5 square root of 3. Please make sure that the one outside, the double is the one outside, and the single is the one inside, not the other way around. And then moving on with, what's the square root of a -1 again? That's an I. So I am inserting I before the radical. And then, of course, I have a 25. So the square root of 3, you cannot simplify that any longer. Can you still simplify these two things right here? Let me highlight that. Can you still simplify the 5 and the 25? I think we can, right? That is both divisible by 5. So 5 divided by 5 is 1. And then 25 divided by 5 is 5. So our final answer is I square root of 3 divided by 5. You could, of course, put the I right after the radical. So you can say that your answer is negative square root of 3 over 5I, right? You can also do that. That is super okay. And you could put 1I, but I usually, if it's just a 1, I usually just don't put it. And that is it, okay? Let's try a couple more examples here. Also, we could also combine radicals. Let's say, for example, ooh, they're both perfect squares, so no problem in there. You have a square root of negative 25 times plus, not times, plus the square root of negative 36. Should I still put this like, okay, for now, let's put that in super detail. Square root of 36, square root of negative 1. So square root of 25 is a perfect square, so that's a 5i plus, that's not, 6i. Oh, they're like terms. 5i plus 6i is 11i. Okay, so we treat this one like a variable. You know how if this was 5x plus 6x, I would have 11x, right? So same idea. So you have 11i for number 2. Moving on. You have a negative 81. Fortunately, still a perfect square. So I have a square root of 81 times square root of negative 1 minus 2 square root of 64 times square root of negative 1. And I think both of them, again, are perfect squares, so we don't have a problem. Square root of a negative, square root of 81 is a 9i minus 2. Square root of 64 is 8i. And a lot of students get this mistake. You know how the 2 is right there before the radical? This means multiplying, correct? So whatever that answer to this gets multiplied to 2. And that's the reason why I am multiplying both of them. And do not forget your PEMDAS, right? You parenthesis, exponent, multiply. So you multiply first before you subtract. So let us multiply before we subtract. 9i minus 16i. And I think we still can combine that into, oops, 7i. So our final answer is negative 7i. Negative 7i, 11i. Okay. Moving on, we have 3i times, remember the dot means times, 3i times negative 6i. Okay, let's multiply the number first. 3 times negative 6 is negative 18. Would you agree? I times I is I squared. You know how x times x is I squared is x squared? I times I is I squared. Same idea. Okay, can we still simplify this? Do we know what I squared is equal to? Okay, if we don't, let's go back to what we talked about earlier. Where are you? Over here. Do you remember this? I squared is equal to negative 1. I squared is equal to negative 1. So whenever we see an I squared, that is just equal to a negative 1. Therefore, I still can simplify this some more on changing the I squared into a negative 1. And so I will have a positive 18. Moving on. 8 times 7 is 56. I times I is I squared. So 56 times negative 1 will give you a negative 56. Okay, I hope that was clear. Now here we have for number 3, I'm going to give you guys, so this is something that you do not have to memorize, okay? But I'm giving you rules on how to get familiarized with it quickly. So we have, for example, I'm just going to write this one and I'm going to prove it to you after. So we have I, of course, I to the power of 1 is equal to I. No problem in there. I squared, we know that from before that it's a negative 1. I cube is a negative I. And then I to the fourth is a positive 1. And I want you to remember two things. Those two. Okay, let's figure out this thing. I cube. You know when you have a like an x, right? An x cube, that means x times x times x. So when you have an I cube, that also means I times I times I. And so I would have either I'll write I times I times I, okay, let's I times I times I. And of course, I times I times I could also be written as I squared times I. Does that make sense? And we know that I squared is equal to negative 1. Yes? So this is negative 1 times I. Therefore, I to the power of cube is a negative I. Does that make sense? Moving on. I to the power of 4. I times I times I times I don't understand again. I times I times I times I. So that is, if you group them into 2, I squared times I squared. That makes sense. And we know that I squared is equal to negative 1, correct? Yes? Okay, so I squared is negative 1, another negative 1. And so negative 1 times negative 1 is a positive 1. And that's the reason why I cube is negative I. Where are you? Right there. And then I to the fourth is a positive 1. Okay, moving on. I to the fifth. Of course, I can just use this information right here, but let's go more like, you know how super in detail. So let's do, what's that? How many I is that? That's too much I, yeah? 1, 2, 3, 4, 5. And then let's group them into I squared, I squared, I. Does that make sense? Does that make sense? So this is 2 i's, 2, that's 4, plus another one, that's 5. And I know that I squared is negative 1, that's a negative 1, that's just I. Negative 1 times negative 1 is a positive 1. Positive 1 times I is just I. Okay, now let's go to I to the power of 6. Woo, that's a lot. Okay, so you either can use this prior information to break that, but you know my goal is to like go deeper, more basic. So I 1, 2, 3, 4, 5, and 6. And then you're like gonna ask, why am I learning all of this? How am I gonna use this one? But you're gonna use this one in the next lesson. So just hold on in there. Let's now group them into, how many parts is this? 3? 3I squared, right? So that's negative 1, negative 1, negative 1. Negative 1 times negative 1 is a positive 1, times another negative 1 is a negative 1. And so we have negative 1 in there. If you notice, we are now following a pattern. I negative 1, I positive 1. And then it went back to negative 1 again. Does that mean this is a negative I? Because you know how I have a negative 1, the next one is a negative I. Does that mean this is a negative I? Let's try. Again, you can use prior information to break I to the power of 7. You see this? That's a prior information. But let's break it into parts where we don't know anything. So we have I. That's a lot of I. 1, 2, 3, 4, 5, 6. Don't worry, it will get better. 1, 2, 3, 4, 5, 6, 7. So let's group them. This is I squared, I squared, I squared, and I. Yes? Because this is 1, 2, 3, 4, 5, 6, 7. And then they go into, this is a negative 1, negative 1, negative 1, I. And negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Negative 1 times I is negative I. See, it went back to the pattern. That means the answer to the I to the power of 8 is a positive 1. Because you see how this pattern right here? Let's see. So now I'm gonna be realistic here, and I'm gonna be breaking this into bigger parts. Okay, so I'm not gonna be doing it I times I times I. That's like too much I. So I'm gonna break the I to the power of 8 into I to the power of 4 and I to the power of 4. I know in the past thing here on letter B that I to the 4 is 1. And so why don't I just do 1 times 1? And that is 1. So I to the power of 8 is 1. Now, what if I have like a number that is like really, really big? What if I have I to the power of 100? Should I do I to the power all 100 of them? That does not seem realistic, correct? And so there are shortcuts to how we remember this. We know, of course, there is a pattern, but I would like you to remember two patterns. We know that I squared is equal to negative 1, correct? So every time we double that, it will become a positive. Is that making sense? So like what I'm trying to say is when I do I times I will get I squared, I'll get negative 1. And so if I have four of them, I squared, I get I squared and I squared. I'll get negative 1 and negative 1. I'll end up with a 1. That means that every time you have a number that is divisible by 2, there will be a negative. And every time you have a number exponent that is divisible by 4, it'll always be a positive 1. Knowing that information, we would be able to survive with this one. So let's say, for example, I'm going to put those in there. So I to the power of square, so I to the power of 4 is equal to I to the power of 8 is equal to I to the power of 4, I to the power of 16, I to the power of 20, because all of them are equal to 1 because they're divisible by 4. They're a number that you can divide by 4. Let's try that. 33, instead of me writing that is too much. So I'm looking for a number close to 33 that is divisible by 4, and that is 32, isn't it? So I could break this. Why am I doing that? Because I know that I to any number divisible by 4 that's equal to 1. So I'm going to break the 33 into I to the power of 32. And of course, I have another one left. And I know that I to the power of 32, 32 is a number divisible by 4. The answer to that is just a positive 1. So this is 1 times I. So my answer is I. As easy as that. Now, I to the power of 30. 30 is a number divisible by 2, correct? Is 30 divisible by 4? No. Right? Because like, miss, because 30, when you say 32, 32 is divisible by 2, but 32 is divisible by 4. So you have to think first, is it divisible by 4? If not, then is it even? And yes, so that's a negative 1. So let's do a 30. 30 is not divisible by 4, but it's divisible by 2, so that's a negative 1. That makes sense. If not, I could break it more. A number that is close to 30 that is divisible by 4. So I would like you to think of a number that is divisible by um 4 that is close to 30, and that's 28. So I could break it into I 28, I to the power of 2. I 2 because 28 plus 2. I know that 28 is 1 because that's a divisible by 4. I squared is a negative 1. You see it's a negative 1 and it's an Easy, easy, easy way of breaking it apart. Now, 15 is 15 a number divisible by 4? No, it's not. Is 15 divisible by 2? No, it's not. So this answer is either an I or a negative I. But let's check. Now, 15 is not divisible by 4. I could go 14 is 14. I could break it either into I to the power of 14 and I to the power of 1. I know 14 is divisible by 2, so that's a negative 1, and that's an I. So this is together, if I multiply those, that's a negative I. Does that make sense? Or you could break it into I to the power of 12 and I to the power of 3. But I already know that if it's an even number, that if it's an even number, for as long as it's not divisible by 4, it's a negative 1. Okay, 80. Is 80 a number divisible by 4? Yes. 80 divided by 4 is 20. So the answer there is 1. So easy, isn't it? Okay, moving on. Now you are going to do your homework. And so your homework is on page 17. If you have any question, let me know. And thank you for listening. I hope this video helped you on how to do pure imaginary numbers. Thank you guys. I will see you on the next video.